This is my second time using Google Slides, I guess is what it's called. So I'm not always sure where things appear on the screen. Before I get started, I wanted to ask a quick question. How many of you work at, let's say, Amazon? Just curious, raise a hand. Anybody here? Just one person? Oh. How about people working at Microsoft? And LinkedIn counts, obviously, right? Okay, cool.
How about people who used to?
Okay, who used to work at Microsoft? Like, I guess I should raise my hand about that. Okay, wow, that's more than interesting. Cool. So my name's Adron, and I'm going to be talking about data in immutable infrastructure, which is something that I've been doing a lot of work with lately, and managing it, and also kind of not managing it, because there's a lot of failure involved in the successes that I've had with what I've been working on. I work at Home Depot, which I hope everyone raises their hand. Everybody knows what Home Depot is, right? The huge place with a lot of orange? Cool. I run what I have been given the fun title of Open Source Ethnography and Site Reliability, which basically means I manage their efforts to get everything open sourced, and I also help them keep their websites going. So the state of the data world, and again, as I just said, I work at Home Depot, and I'm going to be speaking kind of from that context. The state of the data world at Home Depot and in some of our efforts is kind of like this. So there's a lot of things going on, and it gets complex when sometimes it needs to be simple, and sometimes it's too simple when it needs to be complex. So we're always kind of fighting with our data. And one of the things that we've started working toward to make our work with data easier is immutable infrastructure. And one of the tools that we're using is Atlas from HashiCorp and also Terraform. This has given us the ability to kind of clean up our workflow around infrastructure, and instead of having wonderfully handcrafted, artisanal, organically grown, rich servers that everyone loves and cares for, we actually have reliable servers. It's a pretty awesome thing. I've been very, very impressed by all of the HashiCorp tools that I've used. Terraform, Packer, we've started using and looking at Consul a little bit. And it's made that side of things a lot nicer and more reliable for us. The advantages of that have directly impacted us is validated atomic deployments. We've been able to recover back to previous versions much more easily without anyone frantically running around trying to find, well, where was the copy that was on that server for that thing over there? We just literally can click a button and roll back. We also have started doing more experimentation, whereas before, to experiment, we had to hand roll those finely crafted servers and get an environment running, which could take a day, maybe a week, crazy amounts of time. And because of those duplicate environments, we now have a lot of people doing experiments before they just throw things out into deployments, and it's helped us focus our practices and policies around that being a clean, smooth process. In addition to starting to use immutable deployments, we have continuous delivery that's starting to be used by more and more of our projects, including our legacy projects that, I say legacy, I mean, they're like 5 years old, but you know, in tech terms, it's who knows how long ago that really seems like. And that's helped us get to a point where we actually have our stuff tested, and I mean that in many ways, not just like unit tested, but we can test our ecosystem in which something is being deployed out into. We can test for performance or load based on what it's going to need to do, and things like that. It's dramatically lowered our risk of deployments, and we've kind of got to the point where we just assume that when we deploy something and it's in a continuous delivery pipeline that it will work, like 99% work once it's out there. And if anything does fall over, it's like, oh, somebody goofed up a little component in a web grid, or the service is missing one little piece of something. It's something that's very easy to fix very rapidly. So between those two things, the immutable infrastructure and the continuous delivery, that's helped us in many ways get to the point of where we are now, where we at least know we have cats fighting around in the data environment. And we at least have automated systems. The thing about having these automated systems, though, and this is why we realized we have kind of a mess of data in various ways, is we've been neglecting the data the whole time. We're so focused on, well, we're going to get this application deployment so smooth. We have the application deployed, it's out there. Well, it's still got performance issues, or it's still missing this or that or whatnot. And what that keeps driving us back to is we need to get more honed and specific about how we're interacting and dealing with our data. So from a strategic point of view, what that means is we had to step back and ask questions. Because when you're in a big corporation, the first thing you need to do is ask what's going on, because you'll get at least probably 4,000 answers. And you need to figure out what the real point of view really is. So we stepped back and we looked at what we had as far as data. Where is our data now? How do we deploy it? Do we deploy our data, or does it just exist somewhere and never goes away? Or we hope it never goes away, right? One of the things we found is we had a whole lot of SQL servers, ones we didn't even know existed before we started asking. We started to put in some data governance. And at first, me being a more individual contributor focused, where I get into the code and I start to set up systems or implement things like that, I was like, oh, this is boring, I don't want to hear about it. But then, as we started to put the governance into place, I was like, oh, this is actually pretty important. We do need to make sure that we're getting good data and that we're using good data. And that's what a lot of the focus around our data governance has been. And then the data architecture. This was where I started to get a lot more interested in some of our efforts, because we stood back and we're like, well, do those 526 million elements of data need to be in a SQL server? How long does it take to get that report from that server? I go and ask the team that's working on it. Oh, I don't know, 8 hours. I thought, I can help you. So we thought, well, maybe it shouldn't be in SQL Server. So some data has been shifted out, and we've ended up with things in everything from Redis to Cassandra to, I think some stuff is going into MongoDB right now. We have a lot of different systems. And as the kickoff keynote this morning, we have thus become not just a polyglot language environment, but a polyglot data environment. We store it in whatever seems to fit and perform the way we need it to. So that's where our architecture questions really helped us hone in on what we needed to do in that aspect. So I was actually supposed to take out that slide because I couldn't remember what else I was writing there, so I started writing blah, blah, blah. This is what happens as I write slides. I just start putting words in, and eventually I start to form a picture and a story. So then from the tactical point of view, we had those bigger pictures asked, or those bigger questions asked, and we started to have a picture of what we have and where we started to kind of need to go. And the question for us was, how do we get there? One of the things that came up just recently, matter of fact, as I have been churning through things like Terraform and trying to do these deployments and whatnot, I read some blog entries and papers that were produced at Joyent about the Autopilot pattern. And basically, to kind of abstractly describe this, it's the idea of rolling your infrastructure and all of the deployment elements and pieces into your actual application so that it knows where it needs to go, how it needs to go there, and how to scale it out, and all of those elements in with the app. And by respect, I've been kind of extending that and saying we need to also know how that application is really interacting and dealing with our data. So the catchphrase on the site they've put together for the Autopilot pattern is app-centric micro-orchestration. Sounds super fancy. But basically, this is kind of the punch list of some of the things that it helps with and what you're building when you use this pattern. I have attached these pieces. So this is where I also want to talk to anybody and everybody that wants to talk about this later over drinks. We are at the stage where we've started to push pretty hard toward immutable infrastructure and the deployment models that I was talking about. But as we get there, we're like, okay, the data needs to go in Cassandra, or data needs to go in SQL Server, or data needs to go wherever. As we do that, we realize that we still keep pushing out applications, and everything is oriented toward, well, you push the app, but the data just sits there. Sometimes that doesn't meet demands. We need everything new. We still need that data, and that data needs integrity, but the data system that it's in needs to be rolled to. It needs upgraded or version changed or a tweak or a plugin or whatever needs added to it. So I've added this. It's the regressive progressive autopilot pattern. That's what I'm going to start calling it. So it's the RPAP. It's that middle section. Whoops. That middle section where it's kind of shady. Like you have your data in the systems, but those are usually just there. You need your applications to be able to roll changes into the actual server systems that manage that data. One of the systems, speaking a little more tactically, Elasticsearch. We've been using that to do, well, all sorts of things. We do everything from, we use it to monitor our infrastructure, the network, packets coming in and out, basic server performance, what's going on there. And we also use it to do searches against all sorts of products. Like you can go in there and find out about water heaters and things to put on your roof, what type of yard gnome you want, all sorts of things. So Elasticsearch has been super useful. However, who uses Elasticsearch? Yeah. So they move to the next version pretty regularly, and they keep moving along at a good clip. We wanted to be able to, with zero downtime and zero obstruction to like the development teams working on certain other things, we wanted to be able to roll the version, if it's changed, in the application, or the Elasticsearch version in the application so that it could start using the new features. And one of the ways that we've been doing that has simply been to roll together a parallel environment. Like I'm going to try to show you an example. I think I'll do it live. This is one of the things where it's a cool typing sound effect. We just roll up a new Elasticsearch environment, and then we eventually set the nodes, a new master, and then eventually the data replicates over. And that's kind of been working for us. And we just spool it up just like this, and in like 2 minutes, it'll have a fully new built Elasticsearch cluster in Google Cloud. And then as that's replicated over, we eventually have these new nodes, and sometimes we'll have that on the new version, and the old version will have conflicts or whatnot. So it's a little troublesome. On other systems like React, we can literally take the executing executable and not even stop it, put in the new one, and it changes that out. It is a real-time hot swappable version upgrade. But one of the reasons you can do that with React is Erlang. So some systems have this like built in inherently into the idea of the system. Elasticsearch, we still have some issues, because if the versions don't mesh perfectly and you roll up the new cluster, it might not replicate right, or it might not do this or that. It's problematic. And then the other system that we have is SQL Server, and basically it's very simple and very similar, except of course with a relational database we have one key system. It's not distributed out to anywhere in some cluster or some fancy thing like that. But we have our code commits going and our applications up there, and we have it one database that it's communicating with, that it replicates to a second database. And that database is usually whatever the new thing is going to be. If it's like going SQL Server 2014 to 2016, cool. That, whatever that new one is, it's the version, it's the new changes to the tables or whatever, all that. Eventually we switch it out, and we start to communicate with it, and then the old one just gets dropped off to the archive database and everything goes down one, and we spool up a new database for whatever else is going to change in the future, for whatever future development. And that gives us a zero downtime deployment. The only crutch is, of course, as you can see, there's 3 actual full databases. And the way we connect to that with immutable deployments is we actually use an attach-reattach to do that. So we have the replication going on, but when we actually stop and then restart, we use that SQL Server feature. And Postgres and MySQL, same principle. They have the same feature sets around that. So, cheers to managing your data. That's my story right now at Home Depot that we're in the midst of. I'm Adron Hall. I was a Portlander yesterday. I am now a Seattleite. I can be reached at Twitter and GitHub at Adron. I blog at that location. These are some of the things that I've been talking about. I also have all the open source work that we're working on at Home Depot available at those places. We have our organization, and then I tweet about it and put a lot of stuff on GitHub for it. And that's that. So if you have any questions, comments, thoughts, or anything that you'd like to add to what we're trying to do, please talk to me afterwards. I am happy to have many, many, many conversations about this. Thank you.